The gray dawn of June 6, 1944 revealed an English Channel that was a churning, violent expanse of leaden water tearing at the greatest amphibious armada ever assembled in the history of human conflict. The success of Operation Overlord, the invasion of Fortress Europe, did not hinge solely on the strategic brilliance of the Allied High Command, the courage of the airborne troops dropping behind enemy lines, or the massive naval artillery of the battleships offshore. It hinged entirely on the physical and mechanical reality of getting hundreds of thousands of heavily burdened infantrymen across the final chaotic mile of open water and depositing them onto the heavily fortified sands of Normandy. The historical nightmare of amphibious warfare had haunted military planners for decades. The catastrophic failure of the British landings at Gallipoli during the First World War had demonstrated the absolute slaughter that awaited any force attempting to assault a defended beach from the sea. Standard naval vessels, deep draft ships, and conventional transports could not approach the shoreline. They were forced to anchor miles offshore, leaving the infantry to be ferried to the beach in standard lifeboats or clumsy heavy lighters. These traditional boats possessed deep V-shaped hulls that would inevitably ground on the sandbars hundreds of yards away from the dry beach. The soldiers, weighed down by 70 pounds of equipment, weapons, and waterlogged uniforms, would be forced to vault over the high wooden sides of the boats, plunging into deep water under the concentrated fire of enemy machine guns and artillery. The casualty rates for such an operation were calculated to be entirely unsustainable. The Allied planners knew that a direct assault on a major European port like Cherbourg or Calais was tactical suicide, as the German High Command had heavily fortified every deep-water harbor precisely to prevent an amphibious landing. The only strategic alternative was to launch the invasion across open, undeveloped beaches, establishing an artificial logistical lifeline directly over the sand. But this bold strategy required a technological miracle. It required a specialized shallow draft vessel that could carry a fully equipped infantry platoon through rough surf, drive itself entirely onto the dry sand, unload its human cargo in seconds, and then possess the mechanical power to reverse itself off the beach and return to the fleet to repeat the process. The military establishment of the United States, possessing the greatest naval architects and engineers in the world, had attempted to solve this engineering puzzle for years and had failed spectacularly. The ships and craft designed by the Navy Bureau of Construction and Repair were heavy, unseaworthy, cumbersome iron monstrosities that foundered in the surf and completely failed the basic requirements of an amphibious assault. The solution, the vessel that would ultimately save the lives of thousands of American soldiers on D-Day, did not come from the elite naval academies or the War Department laboratories. It came from a loud, aggressive, hard-drinking civilian lumberman from the swamps of Louisiana, a man whom the military bureaucracy had rejected, dismissed, and ignored no fewer than 8 separate times. Andrew Jackson Higgins was a self-taught boat builder who operated a small lumber and marine business in New Orleans. His primary customers were not admirals or generals. They were fur trappers, oil wildcatters, and loggers who needed to navigate the treacherous shallow bayous and the massive debris-choked expanse of the lower Mississippi River. The geography of southern Louisiana presents a unique nautical challenge. The waterways are shallow, filled with submerged logs, shifting mudbanks, and thick abrasive vegetation. A standard boat with a traditional keel and an exposed propeller would be completely destroyed within hours in this environment. To meet the demands of his civilian clients, Higgins designed and perfected a revolutionary shallow draft wooden workboat he called the Eureka. The genius of the Eureka lay in its hull design. Higgins completely abandoned the traditional V-shaped bow, replacing it with a broad, flat spoonbill design. This allowed the bow of the boat to ride up and over floating logs and mudbanks rather than plowing into them. But the most critical innovation, the mechanical secret that made the boat function in inches of water, was the integration of a semi-tunnel hull at the stern. Higgins engineered a recessed cavity running along the bottom rear of the boat, housing the propeller and the drive shaft safely within the wooden structure of the hull itself. A massive heavy-duty skeg, a solid piece of timber, ran directly beneath the tunnel, protecting the propeller from submerged obstacles. This design meant that the Eureka could drive at full speed directly onto a mudbank or a log jam, slide over the obstacle, and continue operating without snapping its drive shaft or shearing off its bronze propeller blades. When the United States Marine Corps, recognizing the looming threat of a Pacific War against the Japanese Empire, began desperately searching for a viable amphibious landing craft in the late 1930s, they tested the standard Navy Bureau designs. The Navy boats were disasters. They were so heavy they required massive cranes to lower them. They swamped easily in moderate surf, and when they hit the beach they dug in permanently, requiring a tractor to pull them back into the water. In sheer desperation, Marine officers reached out to Higgins, having heard rumors of his incredible bayou boats. Higgins brought his wooden Eureka to the military testing grounds and completely humiliated the naval architects. While the Navy-designed craft foundered and stalled, the Eureka, driven by Higgins himself, roared through the surf, crashed onto the beach, and smoothly reversed itself back into the water. The Marines were astounded. They immediately recognized that this civilian lumberman had solved the fundamental physical problem of the amphibious assault. But the Navy Bureau of Ships, the powerful bureaucratic entity responsible for all naval procurement, was absolutely furious. The naval engineers, deeply entrenched in their own institutional arrogance, refused to accept that a civilian with no formal engineering degree building boats out of plywood in a southern swamp could outperform their multi-million-dollar research and development programs. They engaged in a bitter, protracted bureaucratic war against Higgins. They rejected his designs, they altered the specifications required for the testing, they withheld contracts, and they continuously pushed their own inferior heavy steel designs. Over a period of several years, Higgins submitted his proposals and his boats to the various Joint Army and Navy procurement boards and was rejected 8 separate times. The resistance from the military establishment was not merely a matter of pride, it was rooted in a fundamental misunderstanding of what a landing craft needed to be. The Navy wanted a boat that looked and acted like a ship built of heavy steel with a traditional deep draft designed for open ocean survivability. Higgins understood that a landing craft was not a ship, it was an expendable amphibious truck. It needed to be lightweight, highly maneuverable, and completely specialized for the final deadly sprint to the beach. He fought the bureaucracy with a ferocious, unrelenting tenacity. He traveled to Washington demanding meetings, shouting down admirals, and utilizing his contacts within the Marine Corps to force the Bureau of Ships to conduct side-by-side comparative testing. In the final decisive trials held off the coast of Virginia in 1940, the Higgins Eureka absolutely destroyed the competition. The Navy boats failed to clear the surf zone while the Eureka effortlessly delivered its cargo to the sand and retracted without incident. Faced with the undeniable physical evidence and the immense pressure of the impending global conflict, the Navy was finally forced to capitulate. They awarded Higgins the contract to produce his boat for the military, officially designating it the Landing Craft Personnel Large, or LCPL, but the original Eureka design, while brilliant at navigating shallow water, possessed one fatal tactical flaw when applied to a combat assault. The boat had a solid wooden bow. When the craft hit the beach, the 36 infantrymen huddled inside had to stand up, expose themselves completely to enemy fire, and jump over the high wooden sides or clamber over the bow to reach the sand. This meant they were dropping into the water, often stepping into deep holes or tripping over submerged obstacles while carrying 80 pounds of gear. A Marine officer who had observed Japanese amphibious operations in China noted that the Japanese Daihatsu-class landing craft utilized a drop-down bow ramp, allowing the troops to charge directly forward onto the dry beach. The military approached Higgins with this concept, asking if he could incorporate a ramp into his existing Eureka hull. The naval engineers estimated that modifying the structural integrity of the bow to include a heavy steel ramp would take months of redesign and testing. Higgins, operating with the sheer manic energy that defined his career, told them he would have a prototype ready in 3 days. He returned to New Orleans, locked his engineers in the design shed, and completely tore the bow off his most successful boat. The engineering challenge was immense. The spoonbill bow was the structural heart of the Eureka, providing the buoyancy and the hydrodynamics necessary to ride up onto the beach. Cutting a massive hole in the front of the boat threatened to destroy its seaworthiness, causing it to plow into the waves and sink. Higgins solved this by redesigning the forward buoyancy compartments and constructing a heavy reinforced steel ramp that was operated by a manual hand winch and a complex series of marine-grade cables. The ramp was lined with thick rubber gaskets to create a watertight seal when locked in the upright position. When the boat hit the beach, the coxswain operating the winch would release the tension and the heavy steel ramp would slam down directly onto the sand, creating a perfect flat bridge from the deck of the boat to the dry shore. The troops would no longer have to vault over the sides, they could simply run forward en masse, their weapons leveled, ready to engage the enemy the instant the ramp dropped. Higgins built the prototype in exactly 3 days and invited the military brass to New Orleans for a demonstration. When the ramp dropped and a small truck was driven directly out of the boat and onto the levee, the military observers were stunned. Higgins had just created the Landing Craft Vehicle Personnel, the LCVP, the single most important tactical vehicle of the Second World War. The specifications of the LCVP were a masterpiece of practical, brutal engineering. The boat was exactly 36 feet and 3 inches long and 10 feet 10 inches wide. To meet the massive demands of the war effort and to conserve precious steel, Higgins constructed the hull entirely out of marine-grade Philippine mahogany and specialized water-resistant plywood. The use of wood made the boat incredibly light and buoyant, allowing it to achieve a draft of only 2 feet 2 inches forward and 3 feet aft. The power plant was a massive supercharged gray Marine 671 diesel engine capable of generating 225 horsepower. This engine was specifically chosen for its incredible torque and reliability, allowing the boat to push through heavy surf and providing the immense rotational force required to reverse the craft off the abrasive sandbanks. The boat could carry a payload of 8,000 pounds, exactly enough for a reinforced infantry platoon of 36 men or a single standard military jeep and a 12-man rifle squad. The only armor on the entire vessel was a 1/4-inch thick plate of specially treated steel bolted to the exterior of the ramp and small armored shields protecting the two .30 caliber machine gun positions at the rear. The sides and the bottom were completely unarmored, consisting of nothing more than an inch of plywood separating the men from the freezing ocean and the enemy artillery. Having finalized the design, the true miracle of Andrew Higgins began not in the engineering but in the sheer scale of industrial manufacturing. In 1939, Higgins Industries employed less than 100 workers. By 1943, he had transformed the swamps of New Orleans into a massive, sprawling industrial complex employing over 30,000 people. The City Park plant was a marvel of mass production, utilizing continuous moving assembly lines that rivaled the automotive factories of Detroit. Higgins was a social pioneer driven entirely by the absolute necessity of production. He completely ignored the deep-seated segregationist laws of the Jim Crow South. He hired thousands of African American men and women, integrating his assembly lines, paying equal wages for equal work, and demanding absolute perfection from every single employee regardless of their race or gender. The factory operated 24 hours a day, 7 days a week, a deafening, chaotic symphony of screaming bandsaws hammering rivet guns and the heavy mechanical thud of the diesel engines being tested in the water tanks. The production numbers were staggering. At the peak of his operation, Higgins was producing over 700 LCVP landing craft every single month. These wooden boats were loaded onto flatbed trains, shipped to the eastern seaboard, and hoisted onto the massive decks of the naval transport ships preparing for the invasion of Europe. The build-up to D-Day Operation Neptune was a logistical mathematical equation of incomprehensible complexity. The Allied High Command had to move over 150,000 men across the English Channel in a single morning. The vast majority of the infantry assigned to the initial assault waves, the 1st Infantry Division and the 29th Infantry Division at Omaha Beach and the 4th Infantry Division at Utah Beach, would make the final terrifying journey in the plywood boats built by the lumberman from New Orleans. The training exercises conducted off the coast of England at Slapton Sands were brutal and bloody rehearsals. The soldiers learned the agonizingly slow process of transferring from the massive troop transports, the APAs, down the shifting, unstable cargo nets into the heaving LCVPs bobbing in the swells below. They learned the strict loading protocols, the timing required to avoid being crushed between the heavy steel hull of the transport ship and the wooden side of the landing craft. They learned the sheer physical misery of existing inside the open-topped boats, where the diesel fumes mixed with the violent pitching of the ocean, inducing crippling seasickness long before they ever saw the enemy coastline. The meteorological reality of June 1944 nearly destroyed the entire operation before it began. A massive low-pressure system stalled over the English Channel, generating gale-force winds, heavy freezing rain, and massive chaotic swells. General Dwight D. Eisenhower, the Supreme Allied Commander, was forced to delay the invasion, agonizing over the shifting weather reports. The parameters for an amphibious landing were incredibly strict, requiring specific tidal conditions, low winds, and clear visibility. On the morning of June 5, the Chief Meteorologist Group Captain James Stagg identified a brief marginal break in the weather, a narrow window of acceptable conditions that would hold for barely 24 hours. Eisenhower made the monumental decision to proceed, issuing the order that would launch the Armada. But acceptable conditions to a meteorologist sitting in a command bunker translated to an absolute physical nightmare for the infantrymen loaded into the landing craft. In the early dark hours of June 6, the massive transport ships anchored in the designated transport areas 11 miles off the coast of Normandy. This distance was dictated by the range of the German coastal artillery, which could easily sink the stationary APAs if they anchored any closer. The distance meant that the soldiers would have to endure a grueling, terrifying run-in of over 10 miles across an angry, choppy sea. The heavy mechanical davits of the transport ships swung outward, lowering the fully loaded LCVPs into the dark, churning water. The boats hit the swells with bone-jarring violence. The moment the release cables were tripped, the coxswains, heavily burdened in their life vests and steel helmets, engaged the heavy transmissions of the gray marine diesels. The engines roared, their exhausts sputtering thick black smoke into the cold air as the boats pulled away from the mother ships and began the agonizing process of circling in the assembly areas, waiting for their designated assault waves to form up. The interior of an LCVP during the D-Day assault was an environment of profound claustrophobic terror. The 36 men of the rifle platoon were packed shoulder to shoulder, standing up, completely unable to sit or move. The flat-bottomed design of the Higgins boat, which made it so effective in shallow water, also made it pitch and roll violently in the deep-sea swells of the channel. The boat did not cut through the waves, it slammed down on top of them, sending massive sheets of freezing salt water crashing over the unarmored plywood sides and soaking the men to the bone. The combination of the violent motion, the overwhelming smell of the diesel exhaust, and the sheer, unadulterated fear of the impending combat caused an epidemic of debilitating seasickness. Men vomited uncontrollably onto the wooden deck plates, their physical strength sapped before they even fired a shot. The noise was absolute. The deafening roar of the 225 horsepower engine struggling against the massive weight of the water was compounded by the constant concussive thunder of the naval bombardment passing directly overhead as battleships and cruisers hurled tons of high explosives toward the French coast. As the landing craft broke from their circular holding patterns and formed into the long staggered lines for the final run to the beach, the terrifying reality of the German defenses became visible through the gray mist. The coastline of Omaha Beach was not a flat expanse of sand. It was a concave crescent dominated by high chalk bluffs heavily fortified with concrete pillboxes, artillery casemates, and interlocking machine gun nests. Field Marshal Erwin Rommel, the commander of the German defenses, had spent months transforming the tidal flats into a lethal obstacle course. He understood the mechanics of the Higgins boat perfectly. He knew that the LCVP required a clear run to the sandbank to be effective. To prevent this, he ordered the installation of thousands of lethal obstacles directly in the surf zone. Massive steel structures known as Belgian gates, heavy wooden logs driven deep into the sand at an angle and capped with Teller anti-tank mines, and the terrifying steel hedgehogs welded from heavy iron beams designed specifically to rip the plywood bottom out of a landing craft and detonate the mines, instantly killing everyone aboard. The American coxswains steering the Higgins boats through the chaotic surf faced an impossible navigational nightmare. They were young men, often 19 or 20 years old, standing at the rear of the boat, their heads exposed above the armor plating, fighting the heavy mechanical steering wheel against the massive torque of the ocean. The tidal currents in the channel were incredibly strong, pushing the boats far off their designated landing sectors. As they approached within a mile of the beach, the German artillery spotters on the bluffs above recognized the incoming waves and opened fire. The water around the landing craft began to erupt into massive geysers of white foam and jagged steel shrapnel as 88mm shells and heavy mortar rounds slammed into the ocean. The plywood sides of the LCVPs offered absolutely zero protection against high explosives. When a boat took a direct hit, it simply disintegrated, instantly turning 36 men and a massive diesel engine into a horrific spray of blood, wood, and twisting metal, sinking immediately to the bottom of the channel. The survival of the remaining boats depended entirely on the raw horsepower of the gray marine diesel and the sheer mechanical brilliance of Andrew Higgins' spoonbill bow design. As the boats entered the final 100 yards, the shallow surf zone, the true genius of the LCVP, was revealed. Standard boats would have grounded violently, their propellers completely destroyed by the shifting sandbars. But the Higgins boats rode high over the shallow water, the spoonbill bows deflecting the heavy chop, the propellers safely protected deep within the wooden tunnels. The coxswains desperately threaded the needle, weaving their wooden boats through the maze of steel hedgehogs and mine-tipped logs, the sides of the boats scraping against the lethal iron obstacles. The noise inside the boats changed from the roar of the ocean to the terrifying, unmistakable snap and crack of heavy machine gun fire. The German MG-42 machine guns, firing at a cyclic rate of over 1,200 rounds per minute, poured a concentrated sheet of lead down from the bluffs, aiming directly at the unarmored sides and the thin steel ramps of the approaching landing craft. The physical mechanics of the actual landing the moment the boat touched the continent of Europe were brutal and precise. The coxswain, realizing he had reached the outermost sandbank, threw the heavy brass throttle lever completely forward, driving the boat hard into the sand. The spoonbill bow ground into the abrasive aggregate, the kinetic energy of the heavy boat driving it forward until it wedged firmly against the beach. The coxswain immediately slammed the transmission into neutral, holding the engine at a high idle to prevent it from stalling. He screamed the order to drop the ramp. The crewman standing at the heavy hand winch at the rear of the boat released the tension mechanism. The heavy steel cables slacked and the massive armor-plated ramp slammed down into the freezing surf. The moment the ramp dropped, the entire interior of the boat was completely exposed to the interlocking machine gun fire from the German bunkers. For the infantrymen standing inside, this was the moment of absolute truth, the terrifying climax of the entire massive logistical undertaking. The quarter-inch steel of the ramp, which had provided a minimal psychological shield, was suddenly gone, replaced by a clear view of the chaotic smoking beach and the tracer fire cutting through the mist. The soldiers, heavily weighed down by their saturated uniforms, their ammunition bandoliers, their gas masks, and their heavy M1 Garand rifles, surged forward. They did not leap over the sides, they ran straight down the steel ramp directly into the teeth of the enemy fire. The water was often much deeper than anticipated, the boats having grounded on hidden sandbars, leaving deep runnels between the ramp and the dry sand. Men plunged into water up to their chests, holding their rifles high above their heads, wading through the freezing surf, fighting the undertow, while heavy machine gun bullets churned the water around them into a bloody froth. The casualty rates in those first few waves at Omaha Beach were catastrophic, entire platoons cut down before they even reached the relative safety of the shingle wall. But despite the horrific slaughter, the sheer mechanical reliability of the LCVP ensured that the invasion did not fail. Once the infantry had cleared the ramp, the coxswain immediately slammed the transmission into reverse. The powerful gray marine diesel roared, the propeller biting hard into the water. The protected semi-tunnel design allowed the boat to generate massive reverse thrust without destroying its own drive shaft on the sandbank. The boat shuddered, ripped itself backward off the beach, the crewmen frantically winching the heavy steel ramp back into the upright locked position. The empty boat turned heavily in the surf, navigating back through the lethal obstacles, and headed back out to the deep water to rendezvous with the transport ships to load the next wave of infantry and do it all over again. The cycle was relentless. Boat after boat, wave after wave, the wooden Higgins boats ground onto the sand, dropped their ramps, deposited their human cargo, and reversed back into the channel, creating a continuous massive conveyor belt of men and material flowing from the ocean directly onto the contested shores of Europe. If Andrew Higgins had accepted the 8 rejections from the Navy Bureau of Ships, if he had simply retreated back to his lumber business in Louisiana, the invasion of Normandy on June 6, 1944 would have been a physical impossibility. The Allied forces possessed the air superiority, the naval bombardment capability, and the millions of highly trained troops required to defeat Nazi Germany. But without the LCVP, they possessed absolutely no mechanical method of transferring that massive military power from the ocean onto the land. The heavy deep-draft Navy boats would have foundered on the outer sandbars, forcing the infantry to drown in the deep water or be slaughtered as they slowly climbed over the high sides. The steel ramps of the Higgins boats, dropping thousands of times across Omaha, Utah, Gold, Juneau, and Sword beaches, were the literal bridges that connected the Allied armada to the continent of Europe. They were the essential technological requirement that made the liberation of France a strategic reality. The scale of the Higgins contribution to the war effort is difficult to comprehend. His factories in New Orleans produced over 20,000 landing craft during the Second World War. The boats were used in every major amphibious operation in the European and Pacific theaters, from the bloody coral atolls of Tarawa and Iwo Jima to the volcanic ash of Okinawa and the sweeping beaches of southern France. The LCVP fundamentally altered the strategic calculus of global warfare, entirely negating the concept of an impenetrable coastline. The military planners who had mocked Higgins and rejected his Plywood boat were forced to rely entirely upon it to execute the most complex military operations in human history. The wooden boat built by a loud aggressive civilian from the Deep South outperformed the multi-million-dollar engineering projects of the entire military-industrial establishment simply because Higgins understood the brutal physical reality of the shallow water environment better than any man alive. When the war finally ended and the grim accounting of the victory was tallied, the Supreme Allied Commander General Dwight D. Eisenhower reflected on the staggering logistical miracles that had made the defeat of Nazi Germany possible. He did not point to the massive aircraft carriers, the strategic heavy bombers, or the armored divisions. He pointed directly to the stubborn, brilliant boat builder from New Orleans. Eisenhower stated with absolute clarity that Andrew Higgins is the man who won the war for us. He acknowledged that if Higgins had not designed and built those specific wooden boats with the spoonbill bows and the drop-down steel ramps, the entire strategy of the war would have been different. The Allies would not have been able to land over an open beach, the entire invasion of Europe would have been delayed or cancelled, and the course of 20th century history would have been fundamentally altered. The lives of thousands of American soldiers who survived the chaotic sprint across the Normandy sand owed their existence entirely to the relentless and compromising mechanical genius of a man who refused to take no for an answer 8 separate times and forged the very instrument of Allied victory out of plywood and sheer willpower.